In this video, I will talk about how to sum out the vector graphically, and also what is the properties for this vector. First thing, consider that we have a vector A that represented by this arrow. This is a vector A, and we have a vector B, something like this. And for now, these two vectors is enough. The first property is called commutative. It shows that A plus B equals to B plus A. Now, the first thing we have to know is that how we graphically sum out the vector. So let's say we want to sum we want the A plus B, sum out these two vectors. First, we draw the A. Now, this is the vector A, right? And second, we draw the B, the tail of the arrow B at the head of the arrow A. So something like this. This is the vector B. And the resultant vector, let me use the red color. It looks something like this. This red color arrow is A plus B. Okay, so by summing out the vector, we just have to draw out the first vector and continue drawing from the head of the arrow of the first vector to the second vector. In this case is B, and if we have some vector C, we just repeat the process starting from the head of the previous arrow, and then we continue to the next arrow like this. And now I will going to show you the first property. This is a commutative. We already have a result of A plus B. Let's see what we will get if we do the B plus A, this part here. So we first start drawing the B first. This is the vector B, and we attach the vector A to it like this. And you can see here the resultant vector will be something like this. This is the B plus A. You can see these two arrows, A plus B, and the arrow B plus A is a same arrow, right? Pointing toward the same direction and have a same length, right? Same amplitude, that means. So graphically, we already showed the vector are commutative. That means you can add the A to the B or B to the A. The order is not important. Now so far we show only the two vectors. How about we have three vector and more? I'm going to show you the third vector. Let's say this is a vector C, right? Now, well, this still obey the properties. Let's find out. So we can write the something like A plus B plus C. Well, it equals to the B plus A plus C. Well, it equals to the C plus B plus A. A plus A. Well, these things are equal. Now, let's try. So we start with the vector A, say something like this, and plus B. This is the vector A. Now plus B, we draw a vector B, and we draw vector C. Now the resulting vector will look something like this. This red color one is A plus B plus C. we already have this part, the first case. Let's try out the second one. Mm, we start with the vector b, and we plus the vector a, and we plus vector c. Well, again we draw the resultant vector, and this resultant vector actually we can directly start with the first uh, the tail of the first arrow and directly end it the head of the vector to the head of the last vector like this. So this is the case for a plus sorry b. Oh, this is a b plus a plus c, right? And let's try out the last one, c plus b plus a. So this is we start with the c, then we do the b, and last we get out the a, and again you can see this this is a c plus b plus a. You can see this these three arrow here, three red arrow is the same, right? So this is valid, the properties is valid. It shows us the thing are commutative regardless how many vector we have, and the order of adding all this vector is not important. Actually, this also lead us to the second properties, which is called associative. In this case, you can see this. If we do the a plus b first, let me redraw it. For example, we do the a plus b first, and then we add our c. Again, you can see we get the same vector here. This is a case for a plus b plus c. Now the second part here, we try out doing a plus b plus c. So we do the b plus c first because they have a bracket here. We do say b plus c, and then we add back the a because here the bracket we prioritize the a plus c. Now you can see this the resultant vector here. We sum out all the vector. Actually, they will give back the a plus b plus c. This is the case, and you can see these two are actually the same vector, right? That means this obey the associative properties. The last one is distributive. In this case, this m is constant. We use the n as a constant, right? Good. Ah, let me draw back the B and the C. Okay. So let's say we have a plus B. Now the A is something like this. Uh, B is something like this. This is A and this is B. Right. Remember the resultant vector will look something like this. Let me change the color. This is a resulting vector. Now, if we multiply a constant here, actually depends on whether this is greater than 1 or less than 1. If this m is greater than 1, they will become longer, with higher magnitude than this a plus b. If m is less than 1, there will be a shorter, right? Uh, Now this is just a constant. We can assign any value to it. Depends on the physical situation. In this case, I will let this m equals 2. That means this we will scale out this thing a plus b by 2 unit. That means we get something like this. This is 2a plus b, right? Here you can see this is 1 unit of a plus b, and here become a 2 unit of a plus b, right? Now you can see one thing is that if we scale out the a and b uh, individually, so this case this is we get 2a and 2b. So we can see here 2a is something like this. We scale out the vector a by 2. This is a 2a, and we scale out vector b by 2, and we add it together. Right, this is a 2b. You can see if we draw it, draw the resultant vector. This will just, you can see this arrow here and this arrow here are just the same, right? Pointing toward the same direction, have a same length. So we can conclude this: the for any constant n multiplied with the a plus b is equals to the m, the constant multiplied with a plus a constant multiplied with b. That means this is equals to the scale of this constant multiplied with each individual vector. This is what we know as the distributive properties. So here is some basic properties of a vector.